Alright, here we have the notes for section 4.4, which deals with proving congruence in triangles, dealing with SSS, which is side, 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 and SAS, side, angle, side. So, main ideas, use the side, side, side postulate and the side, angle, side, and their new vocab, the included angle. So, here we have postulate 4.1, which is the side, side, side postulate. That says if the sides of one triangle are congruent to the sides of the second triangle, then the triangles are congruent. So if you can prove all three sides of one triangle are congruent to the three sides on the other triangle, the triangles are themselves congruent. Now, if you can read this down here, please be careful with how you name it, because remember, when triangles are congruent, you have to have corresponding angles in the same order. So A, B, C, the angle that matches A is actually angle Z, so that's why this is ZYX, not XYZ. So you can name the triangles however you want. But when you're saying that they are congruent, you have to have the matching corners with each other. A with X, A with Z, B with X, C with Y. So here, write a two-column proof. Given that A, B, and AC are congruent, BX and CX are congruent, prove the two triangles. So for statement and reason, so remember your first statement is always the given. So AB congruent to AC, BX, I leave myself a whole lot of room, congruent to CX, that is given. So I know that A, B, and AC are congruent, BX and CX are congruent. So I need the third side of the triangles proved congruent before I can use side, side, side. But if you look here, these triangles share a side. They share side AX. So what I can say is that AX is congruent to AX because this is the reflexive property. Now, so triple hash there, so now I have all three sides congruent, so I can say that triangle BXA is congruent to triangle CXA. The reason is side, 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 or you could write postulate 4.1. Either way works. Alright, so here's the case where you have two triangles on graph paper. You can do a similar thing if you remember classifying the triangles to scalene, isosceles, or equilateral. Similar thing. So for example, that's 3 by 3, which means that that's the square root of 18. That's 1 by 4, so that's the square root of 17. That's 1 by 4, that's the square root of 17. Over here, 1 by 4, so that's root 17. 3 by 3, that's root 18, and that's 1 by 4, so root 17. So this triangle has a root 17, a root 17, and a root 18. This triangle has a root 17, a root 17, and a root 18. So these triangles are congruent because the sides are congruent to each other. So the second postulate for this section is 4.2, deals with side angle side. So the angle that's formed by two sides of the triangle is called the included angle. So for example, on this triangle, side AB and side CB, the included angle is B, the angle in between them. So this postulate says if two sides and the included angle on one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So same thing here, pay attention to the order you name the letters. A, B, C is F, D, E. So the order matters. Okay, and last one here, write a two-column proof. So statements, reasons. So always start with the given. So 1, X is the midpoint of BD, X is the midpoint of AC, given. Now if that is true, if X is the midpoint of BD, that means that those two are congruent. So DX is congruent to XB. You can do the same thing on the other line, AX and CX are congruent. Both of these are the definition of midpoint. Now the last thing I need to prove is that this angle here is congruent to that angle there. So I need to say that angle DXC is congruent to angle AXB. Now you can do that because these two angles are the opposite sides of the X, so they are vertical angles. And then 5, the last one is the proof statement. Triangle DXC congruent to triangle BXA. The reason for this is two sides and the included angle, so side, angle, side is the reason. And there we have the end of the section.